let's go to where we left off, right here. So basically, Venn diagram was our last topic. We'll be doing more exercises on the Venn diagram before we finish today. We need to understand the formal definitions now. Formal definitions for the intersection. For that, I have two examples. Now look at these examples. If the set A equal to this and B equal to this, then A intersection B would have 3 and 5, because 3 and 5 are the common elements. So basically, A intersection B has the element 3, for example, because it is in A and in B. That's the reason. Same reason for 5. 5 is in intersection because it is in A and it is in B, 5. Now, the 2 is not in the intersection because 2 is in B but not in A. So it has to be in both. And that's why the formal definition goes this way. A intersection B is equal to set of all x such that x belongs to A, x must be in A, and x must be in B. Only then it'll be in the intersection. All right, similarly, the union. Let's look at the union. A union B would have 2, 3, 4, 5. The 2, 3, 5 are here, and 4 is here. So therefore, 4 will be added to the union. So basically, everything here and everything here are collected together in the union. But when we write formal definition, we have to use this set builder notation. So in the same way we described intersection, I'm trying to describe the union here. So if I say A union B equal to set of all x, then what can I say inside? X belongs to A. I cannot say X belongs to A and X belongs to B. That would mean X must be in A and in B at the same time. That's what it would mean. But how can we describe it in here? Anybody?
Or.
Or is correct. Very good. Because see, the 2, for example, is in the union because 2 is in B, it's not in A. So if it is in either one, B or A, it has to be in the union. So similarly, 4. 4 is here because 4 is in A, even though it's not in B, it'll be in the union. So anything that belongs to either one will be in the union. That's essentially what we need to say. So the proper way to describe that inside this set builder notation is to say set of all x such that x belongs to A or x belongs to B. So the word is or here. So what you need to remember is whenever it's intersection, the word is and. Things that are in both A and B will be the intersection. Things that are in A or B will be in the union. So the two words corresponding to it. That is going to be the key to answering a lot of questions in this set theory and later in the probability theory. You know, connecting these words to the intersection and union will be the key. So that's why I wanted to highlight that. Now there are, before I proceed, anybody has any question from last class discussion or homework or anything like that? I can take them up first. I forgot to do that at the beginning.
Yes, I actually had a question about number 2 as well as number 5.
The homework?
For number 2, yes.
The homework. All right. Let's number 2. Is that the problem? 40% solution, 90% solution?
Yes.
Okay. Suppose that one solution contains 40% alcohol and the other solution contains 90% alcohol. How many liters of each solution should be mixed to make 8.5 liters of 70%? So the mixture should have 70% solution. So how much of each should be mixed is the question. So
Um,
yeah.
Actually, I think for my problem, it said 60% before.
Oh, yeah, that's each one of you get different numbers and I got different number here. I'm going to work with these numbers and you should be able to figure out how to do yours, right? 1 second. Yes, everything that shows in red would be different for each one of you. The homework assignment is always a different version for each student. So what I have here is not exactly the same problem you had, but I'm going to do this problem. The method of solution is going to be same as how it would be in your case. Okay, so or do you want me to work with your numbers? I can do that if you want, if you have those numbers.
No, it's fine. You could work with the numbers you had. I just didn't know how to go about this problem.
Okay. So one is 40%, the other one is 90%, and we need to mix a certain liters of the first one and the second one. So I'm going to call X liters of first and Y liters of second to be mixed. And the combination should have 8.5 liters. So right there, that means X, the number of liters, should add up to 8.5. So that's one equation. After that, the total amount of alcohol in the mixture should be equal to 70%. So the amount of alcohol is, in the first one is 40% of X, 40% of the entire liters will be the alcohol. So that will be 0.4. 40% is 0.4 times X, right? 40% of X is 0.4 times X. So this is the amount of alcohol in the first solution. Plus, the amount of alcohol in the second one is 0.9 Y. This is total amount of alcohol. That must be equal to the total amount of alcohol in the mix. That would be 70% of the mix. So 70% of what? 8.5. The volume of the mix is 8.5, right? So 0.7 times 8.5. So that's your second equation. 70% of total volume of the mixture. That gives you total alcohol in the mixture. Should be equal to total alcohol coming from each. That's your second equation. Okay, you got it?
Yes.
Yes. Moving to the next one. What's the other one?
Number 5.
List the elements of the set in raster notation. So right now it's given in the set builder notation, and you need to rewrite it in raster notation. That means list the actual elements that are in there. Basically, it says set of all x such that 6 minus x equal to 7. In other words, all the x's that satisfy the equation 6 minus x equal to 7 will be in this set. So that means you need to solve this equation. So subtract the 6, then minus x equal to minus 1. So x equal to 1. That's the only solution. So therefore, the set can be rewritten as 1 in it. This is your raster notation for that set.
Okay, I just had an issue with this problem because when I try to write the notation, I kept having an issue. Like either trying to write a equals -2 or just trying to put in the -2. But I think it was just like the computer systems, like the calculator not popping up.
Calculator?
Yeah, like the math symbols.
The math
And
symbols, yes.
yeah.
You don't need that. You can type the curly bracket and the -1. You may have forgotten to type the curly brackets. That might be a problem.
Yeah, it was.
Actually, x is -1. There was a mistake I made. So it's -1. So just -1 is the set. And you had to put the curly brackets, otherwise it will mark it wrong.
Okay,
Professor, I
thank
had
you.
the same problem. So I didn't put the brackets, so it marked it wrong, but I had the right answer.
Yeah, that's one of the reasons why you get 3 chances. You had to figure out what went wrong within the 3 chances. Okay.
I understand, but it says list the elements of the set. It doesn't say write the whole set. So
List the
brackets are-
elements of this.
yes, I just list the
Yeah.
element, which is -1.
I see. Okay. I see what you mean. It is written in a confusing way. They should have said list the set in raster notation.
That's right. That's my point.
I know. That's a misleading statement there. So what, you got it wrong?
Yes, I got it wrong because, well, I got the answer right, but it didn't count as the right
Okay.
answer.
Just send me a reminder. I can always add the point back.
Sure. All right. Thank you.
All right, I'll do that. Yeah, if you run into a situation like that, let me know. I can always, I have the access to your grade. I can change.
Professor, I ran into the same problem too with that question.
Oh, with that question, same thing?
Yeah, like I
Alright.
put -1 and it was like wrong.
All right, send me that reminder. I'll change it.
All right.
There is a way I can report errors in the problems to Cengage, so I'm going to report that. It's not an error, but it's misleading statement. Definitely needs to be changed. So yeah, I'll report that to them. All right, so Samantha, you have more questions?
No, those were my only 2 problems that I had issues with. Thank you.
All right, you're welcome.
The 10th question, I have a problem with that.
Which one?
The 10th one.
10.
Yeah.
Okay, let's take a look. A equal to, all right, A has all the elements listed. B has the set builder notation. Are they equal is the question. Okay, so X is a multiple of 7. B says X is a multiple of 7. That means all the numbers that are multiple of 7 will be in there. That's infinitely many numbers are there, right? Multiple of 7. But A has only a few numbers that are multiple of 7. So they're not equal. A is subset of B is true. Everything in A are multiple of 7, so they will be all in B. But B has more elements than A, so they're not equal.
Okay, got it.
All right.
Got it. Thank you.
Can you see the 13th one?
Sure. Okay, 13. Set A has A, E, I, O, U. Set B has vowels in English language. That's what they are, A, E, I, O, U. So they are equal.
What about Y?
Y is not a vowel. Only A, E, I, O, U are vowels. Okay.
Okay.
Anything else?
Can we see problem 3? I think it's 3. I had a little problem. It was just setting it up. I kept getting these wild numbers.
Number 3. All right, Cutter and Andrew bring soft drinks and chips for a club party. They buy them at the same store. Cutter buys 5 6-packs of soft drink and 4 bags of chips. So, okay, different purchases amount to different prices. So basically the question is, what is the purchase price? What are the purchase prices for them? Let me read that. Madeline offers to buy them for the purchase price. And how much should they pay? Should she pay? So purchase price is the question. Right, going to the board. So the prices are unknown. So the soft drink will call price for the soft drink will be X. X dollars. So X and Y are dollars. The other one is chips. So chips will be Y dollars. Then in the first purchase, 5 6-packs of drinks. So that'll cost you 5X, right? Each 6-pack costs you X dollars. He's buying 5 6-packs, so 5X. 4 bags of chips will be 4Y. That's the total cost of the first purchase, equal to 32.30. Okay, are you with me so far?
Yes, I am.
All right. Second purchase cost $29.20, and that was for 2 packs of soft drinks. So 2X is the cost of that, plus 6 bags of chips will be 6Y, equal to $29.20. That's your equation. Got it?
Yeah, I got that part.
All right.
Which I guess it's the decimals that probably threw me off as far as the numbers go.
The decimal is because it's $32.30. You can't ignore the 30 cents, right?
Yeah.
Yeah.
Okay. All
So
right. Thank you.
keep them as a decimal. We don't need to eliminate the decimals because our the numbers in front of the X and Y are whole numbers. That's all that matters. So we don't need to worry about those decimals. Just keep them decimals. If you multiply them
Okay.
by 100, it will be too big.
Okay.
All right. Okay.
All right. Thank you.
You're welcome. Anything else, anybody? All right. I'm going to move away from that. So we have completed the formal definitions. For any, now exercise 16 says A and B are 2 given sets. So A union B, comparing A and A union B. Would you agree A is a subset of A union B? Is that true? Do you agree that it's true?
Yes.
Yes, because A union B contains everything in A and B together. So everything in A must be in A union B. Okay, so is this always true for any sets A and B?
Yes.
Yes. What about this?
I think it's true.
It is true. A intersection B is going to be elements that are in A and B, so they had to be in A. Everything in intersection must be in A. That's always true for all sets, any set A, B. Is this true for any 2 sets A and B?
Yeah.
Yes. So all these 4 statements I have written here are true for any 2 sets A and B, no matter what they are. All right, let's understand complement. That's our third operation. Now, remember I said there are 3 set operations, just like the operations with numbers that we do, plus, minus, and multiplication, division. For sets, there are 3 operations. Integration, intersection, union, and complement. So let's understand the complement now. Complement is written as a bar. So the notation for the complement of A, there are 3 notations, unfortunately. A and then a bar on top of it, we read it as a bar, and then A with prime. This is read as prime, A prime. Also A with the C as exponent, C exponent, we read it as a comp or complement, a complement. So all 3 notations represent the same thing. Unfortunately, there are 3 notations and different books may be using different notation. So you need to be you need to understand that all three of them are the same. And so whichever symbol they use, you have to correctly identify that as complement. So basically complement of A is all the elements of the universal set that are not in A. So everything that is not in A will be the complement. So here's an example. Whenever they give you a problem on complement, they will clearly identify what the universal set is. Otherwise, it's, you cannot guess. Universal set that you can guess can be more than one. So they have to clearly tell you exactly what it is. So in this problem, universal set has numbers 1, 2, 3, 4, 5, 6. And A has 2, 4, 6. B has 1, 2, 3, 4, 5, 6. Then A bar would be everything that is not in A. So what are the elements of universal set that are not in A? That'll be 1, 3, and 5. So therefore, A bar contains 1, 3, and 5. Now look at B. B has 1, 2, 3, 4, 5, 6, which are all there in the universal set. So that means what is complement of B? What are the elements that are not in B? Nothing. So in that case, your answer is empty set. B bar is empty set is the answer. All right, so going to an exercise. Exercise means you have to do it.
Question?
Yeah.
What would make the B bar a no solution?
No solution is not the answer. There's a solution here. So B bar means complement of this set. Complement of this set means the elements that are in the universal set. What are the elements that are in the universal set that are not here? None. Agree with that?
Yes.
That means the set that has nothing is your answer. The answer is a set that has all the elements that are in the universal set, which are not in B, will be the answer. All the elements in the universal set that are not here are none, and that means the set is empty. Okay, so your answer for the complementary set is always a set. If that set has nothing in it, then that's when we say it's empty set, right? So no solution is not the answer. There is a solution, which is empty set.
Okay.
All right. Okay, so given universal set equal to A, B, C, D, E, F, G, and set A equal to A, B, C, and B and C are given, what is A bar is the question. If you normally I would ask everybody to do it in class and I walk around and check everybody, but we have to do it differently now. So let me see if anybody can answer that. What do we have in A bar?
D, E, F, G.
D, E, F, G is correct. Very good. Someone else for B bar.
B, D, E, G.
B, D,
B, D, okay.
then E and G.
E and G. Right. Very good. A complement, which is same as saying A bar, bar. So if I have a bar, so let me go to the board. If I have A bar, which is, we already found A bar in the part A, which is D, E, F, G, right? And if I want the complement of this, that's what it means to say A bar, bar, or A complement, complement. They're both the same. That means what are the elements of the universal set that are not here? And what are they?
D, E, F, G.
A, B, C.
Or no?
D, E, F, G is what we have in A bar. We are now finding complement of this, right?
A, B, C then.
Yeah, yeah, someone said it. Yeah, what is that again? A?
A, B, C.
A, B, C. The elements that are not here, elements of the universal set that are not here, not in A bar, are A, B, C. Now, the set containing A, B, C, isn't that the A? Go back and look at the A. That's A, isn't it? So basically what I'm showing you here is, if you take a complement and then take complement of that, you will be back to A. So A complement is A. That's like negative of -5 is 5. Okay, similar to the math. So that's a fact, that'll be helpful to remember.
So I'm sorry, but I think I need some more clarification on how do you find A bar
Okay,
and A prime and B bar and A comp? Because I'm not really sure what are you guys looking at to like get
all
the
these
answers.
things, all these 3 different notations mean the same thing. They're all complement of the set. And the complement means everything that is not in A should be collected. That's what the complement is. Okay, so looking at the set A, going back to the worksheet, A has A, B, C. So A bar or A complement would be everything that is not in A, but in universal set. Everything in the universal set that are not in A would be D, E, F, G. Agree with that?
Yes, okay.
That's why A complement has, going to the board, A complement is equal to D, E, F, G, right there. Okay?
Okay. And then when you're finding B bar, how would you look at that?
Not B bar, A bar. B bar, oh, we'll do that in a minute. All right. Yeah, I skipped the part B. That's your question. All right. Yep. So let's go over the part B. Part B is about B bar. Let me get the pencil. Part B is B bar. Okay. Can somebody tell me what it is? Oh, I already did. I'm sorry. B, D, E, F, G, E, G, because B, set B has right here, ACF. So B bar, the complement, will have everything that is in the universal set and not here, not in B. So can you see that? B,
Yes.
E, E, G are the ones, right?
Yes.
Okay, all right. So that's B bar. Now the next question is A complement, which is same as saying A bar bar. So let me erase this here. So we want to find A bar bar. So you see that A bar has this, D, E, F, G. Okay, A bar has D, E, F, G. I want to find A bar bar. That means complement of this set, right? Which means all the elements of universal set that are not here. Isn't that ABC? Are you with me, Samantha?
Yes.
Okay, so A bar bar is ABC. Isn't that same as A?
Yeah.
Okay, so that's what I was trying to prove. A complement is back to A. Just like minus of -5 is 5. And that's a fact. A bar, A complement is A. Okay, now what can you say about A union A bar?
Is
Anybody?
it A, B, C, D, E, F, G?
Yes, A, B, C, D, E, F, G, which is same as universal set, right?
Okay.
So if you take any set and combine it with the complement, you're going to get universal set. And that's the fact. I just wanted you to see it. Because everything in A and everything in outside of A combined has to be the universal set, because A bar would be everything that is not in A. So if you combine them, you will get the universal set. So can anybody tell me about A intersection A bar?
It's equal to phi.
Phi,
It's empty.
set. Right, it's empty set. A intersection A bar is empty set. So here I'm repeating the same facts again here in exercise 18. A union A bar is equal to universal set is true for any set A. No matter what set you're dealing with, if you combine any set with the complement, you will get universal set. If you take intersection of any set with the complement, you'll get empty set because there's nothing going to be common to that. A complement is always back to A. These are true for any sets. Okay, now we need to do another exercise. So I want you to do them on your paper. So first part says A union B bar. That's bar on top of A union B. So that means you have to first find A union B and then find the complement. If it has individual bars like A bar union B bar here, this is different. This is different from the part D is different from the part A. Here, you're combining A bar and B bar. That's not same as A union B bar. They're two different things. So to do this first part, you had to first find A union B and then the complement. Okay, so let me see if you can find the answer.
Is it D and G?
Okay, A union B, D and G is incorrect.
It's DEG.
DEG is correct, right. Okay, very good. So DEG. A bar intersection B bar. To find that, you had to first find A bar, then find B bar, and then find what is common to them. So I want all of you to do that one now.
Is it F? Or no? No. No. I think it's no.
A, B, C, D, F, G. So these sets are same as the previous problem, exercise 17. So A bar is D, E, F, G. Okay, I'm writing on the board. A bar is D, E, F, G. B bar is B, D, E, G. Yeah, B, D, E, G. Okay, so what is A bar intersection B bar?
DEG.
DEG is correct. Okay. Okay, so that is correct answer for part B. Let me write that here. Now you need to work on the part C, A intersection B bar. To find that, you had to find A intersection B first. Okay, can somebody tell me the answer?
It's BDEFG.
Did you say B, D, E, F, G?
Yeah, BDEFG.
Okay, let's see. A intersection B is going to be A and C. So complement of that is B, D, E, F, G, correct. Okay, so we have the three parts going on to A bar union B bar. This means you had to find A bar first, B bar, and then combine them. We have A bar up here, D, E, F, G. B bar is D, B, D, E, G. So what is the union?
BDEFG.
Right. Okay. Going to part E. A union B bar intersection C. So this means you had to find A union B bar first and then intersect with C. So A union B bar, we already found up here. If you didn't find, you had to find it first. So the question is, what is common to this and the C? C is up here.
E, F, G,
D,
or D, E, G.
D, E, G, right. So D, E, G will be the answer to this. D, E, G, okay. A intersection B intersection C. A intersection B bar intersection C. So you had to first find A intersection B bar. A intersection B bar is up here. We found it here. And that's equal to this, B, D, E, F, G. So what is common to this and C is what we need to find. Anybody?
D, E, F, G.
D, E, F, G is correct. Okay. Finally, A intersection B bar union C. We have A intersection B bar right here, already computed, and we need to combine that with C. That'll give us B, D, E, F, G. Yeah, same as A intersection B bar. B, D, E, F, G. All right, so let's write that. B, D, E, F, G. Okay, now we are finished with that. Now take a look. A union B bar means combine A and B and then take complement. And that happens to be equal to A bar intersection B bar, right? They're both same. It's not coincidence. They are actually always equal. A union B bar and A bar intersection B bar are always equal. And we will be proving it in a few minutes. Another thing you can notice is A intersection B bar. You take intersection first and then take complement. And that seems to match A bar union B bar, right? And that's also not just coincidence, it's a fact. It's always true for any two sets. And these two facts are given the name De Morgan's properties because De Morgan is a mathematician who contributed to most of the set theory. So it's not just this rule, it's a huge portion of set theory was his work. And so his name is given to those. De Morgan's properties or laws, some books will call them laws. The point is this, if you take union of two sets and then take complement of it, that's same as finding complement of each and then intersecting, opposite operation. Union and then complement is same as complement intersection. Union first, complement after is same as complement first and intersecting, opposite operation. Similarly, taking intersection first and then complementing is same as complementing first and then taking union, opposite operation again. And these two properties you have to remember. Remember upside down. But upside down, what I mean is, whenever you see A union B bar, you should know that it's equal to A bar intersection B bar. And backwards too. If you see A bar intersection B bar, you should recognize that it's same as A union B bar. You should be able to go back and forth. If you are familiar with it that much, then a lot of the problems you'll be doing will become easier. These theorems, these facts make the problems easier to solve very often. And that's why they are important to remember. So we're going to prove these De Morgan's laws by using the Venn diagram. Venn diagram is one easy way to show that two things are equal. So let's do A union B bar. Let's start with that. I have two pictures here because, I mean, in class, I ask students to shade the region that represents A union B bar. And then on the other picture, shade the region that represents A bar intersection B bar. And then you can see that they're the same. That's the idea. But I'm going to have to do that myself and explain to you because I'm not able to see what you can do on the paper. So let me clear the board. And But right now we are verifying the first de Morgan's law. So we need to find A union B bar first. So I will in this picture, I will show you the A union B bar. This is A and B. So A union B is A and B combined, right? So what should I shade for? Well, before that, sorry, I should have asked a different question before that. A bar on the Venn diagram. So here's the Venn diagram. This is A. The problem says shade A bar. What do I shade?
The part outside the A circle.
Right. The entire universal set outside the A. Everything outside the A that's in the universal set. This is your A bar. Okay, now going back to this picture, I need to shade A union B bar. What do I shade here in this picture?
The part outside of two circles.
Right, everything outside of the two circles. Very good. Okay. So this is A union B bar, the region I shaded. Now I'm going to clear up the second picture. And let's work out the right side of this equation, A union, A bar intersection B bar. We need to prove that these two are same, right? These two are same. To prove that, we worked out the first one on the Venn diagram. Now we're going to have to work out the second one. Okay, I'm going to work that out on the board. A bar intersection B bar. Okay, A bar intersection B bar. This is A and this is B. To figure out the intersection in this picture, it's going to be a little bit complicated. So what I'm going to do is I'm going to do the work using colors. So I'm going to show the A bar shaded in red, A bar in red. All right. So A bar would be everything outside of A. So I'm shading it in red. Everything I'm shading in red is complement of A. We already saw how to figure out the complement of A. Part of B is in the complement of A. All right, everybody agree on that? Okay, going to change the color to do the B bar. B bar is everything outside of B. So I'm going to shade that in blue. Everything in red is A bar. Everything in blue is B bar. Outside of B, which includes part of A. Okay. Now the question is, what is the intersection of A bar and B bar? Now, A bar is in red and B bar is in blue. So the intersection means intersection would be common to both. That would be the region that's shaded both red and blue, isn't it? Agree with that? All the red areas are A bar. All the blue areas are B bar. So asking to find common area is same as asking what region is shaded both blue and red. And what region is that?
The part outside the circles.
Outside the two circles. Is that same as the first picture?
Yeah.
Yes. So that proves the De Morgan's first law. A union B bar is equal to A bar intersection B bar. We just proved it. Any question on that?
So
Okay.
would it matter that you ended up marking inside the circles?
Well, the inside the circles are either red or blue, right? They're not red and blue. Intersection will be red and blue. Agree with that?
Yeah, that means that they'll be like combined if they were intersected.
Right. So what is common to blue and red is same as asking what area is blue and red, and that's outside the two circles. So therefore, A bar intersection B bar is outside of the two circles. So that matches the first picture. So therefore, they're both same. A union B bar and A bar intersection B bar are same. We just proved it. Feel free to ask question if you're not following this. I can explain again. All right, now I'm going to go into the second De Morgan's law, which says A bar intersection B bar. I'm sorry, not that. The second De Morgan's law is A intersection B bar is same as A bar union B bar. Okay, so we're going to work out both in two different pictures and show them that they're equal. All right, my first picture is going to be A intersection B bar. So A intersection B would be the common area for A and B, right? We did that in the last class. So isn't that this area? Agreed? Okay, so I need to find the complement of that. I'm looking to find A intersection B bar. That means everything outside of this middle section. And that's going to be everything I'm shading here. Only area not included is the intersection. Clearly, that's what it means to say A intersection B bar. Everything outside of this is middle section. All right, I assume you understand that so far. Now I'm going to work out the other one, A bar union B bar. A bar union B bar. Okay, so again, I'm going to use colors, but this time it's union. Union means I need to combine the two things, A bar and B bar. So I'm going to use A bar. I'm going to shade A bar in one color and B bar in another color again. So I'll use red color for A bar. I'm shading A bar in red. Everything outside of A, and it's partly in B. Okay, so all that is in red is A bar outside of A. Now I'm going to use blue color to shade B bar. And so B, everything outside of B is shaded in blue. And after that, our question this time is slightly different. Last time, our question was what is common to both? When you ask what is common to both, it'll be the region that's shaded in both colors will be the common area to both. But the question will be different this time. So B bar is this. Okay. This time the question is, what is the union? What is the union of the red shaded region and the blue shaded region? So that's same as saying what region is either red or blue. Agree with that? Remember the word is or. If it belongs to A bar or B bar, then it'll be in the union. So what region, whatever the region that is shaded in red or blue is going to be in the union. And and so everything in red or blue should be combined. And so what region are we getting? Can you see that? It's
The whole area without the intersection part.
right, everything outside the common region, intersection part, right? Everything outside of this region. Everything outside of this is either red or blue. Isn't that same as what we have in the first picture? So
Yes.
yes, that's why De Morgan's law is proved. So we just proved the two De Morgan's laws. They are actually equal. So here we go with the problems. These are exercises for you to do. So I guess I just have to ask you to tell me what region to shade. Anybody for the first question? A intersection, B complement. What region would that be?
It's the whole area without the intersection part.
Right, everything outside the intersection, everything outside the common region will be the answer to that. Very good. Let's go to the second one. If anybody is not following me, please feel free to ask the question. We're going to the second question, which is A union B complement. What region should that be?
Would it be everything including the intersection?
You mean A and B combined, including the intersection?
Yes.
That would be A union B. But what we need here is A union B complement.
It's the
Outside,
whole area outside the two circles.
right, the whole area outside the two circles. That's right. Very good. Okay.
So whenever we're trying to find a complement of two circles, we're always going to start from circulating like outside.
No. The question here is, I'm going to put it on the board. The question here is, what is A union B complement? A union B is the two circles combined, right? And then when you find the complement of it, that would be outside of the entire set. Okay?
Okay, so yeah, I was just asking when we're shading the circles, it would just always be outside of the circles.
Right. So
Okay.
if the question is what is A union B, that would be two circles. You will be shading both circles.
Yeah, inside. But if it's to complement, it's outside.
That's the question here. So you'll be shading everything outside the two circles.
Okay, thank you.
You're welcome. Going on to question number C. Anybody identify the solution to that?
It's the part in the middle, but not the whole part.
Okay, you mean to say, let me copy
Center.
that.
The center in the C circle, I think. They intersect where the C is, I think.
Yeah, I think you got it, but I'm going to, all right, I'm going to draw that. So I'm drawing the picture. So what is common to A and B would be this center portion, right? Well, what we are trying to find is what is common to A, B, and C, all three of them. So your solution is that this part?
Yeah.
Yes, that is correct. This is the part that is common to all three of them. So that's what you shade. Okay, B bar intersection A. Can somebody answer that? B bar intersection A?
It's the part in the A circle, but without the intersection part.
Right, part of the A without the intersecting part. Very good, you got it. So let me show you. B bar intersection A. I'm going to, just to make sure everybody understand it, this is A, this is B, and B bar would be everything outside the B, everything outside the B, that includes part of the A. So what part of this is in A? That's the question, right? B bar intersection A means what part of B bar is shared with A. And that would be this part, isn't it? This part of A is shaded right now. So B bar intersection A means what is common to A and the outside of B. So what is common to A and the outside of B is this. So that's your answer to that. right? So what would be A intersection, A bar intersection B? Anybody?
It would just be B shaded.
Entire B shaded?
Yeah.
Entire B will be B. The A bar intersection B is not equal to B.
It's gonna be B without the intersection area.
Right, the part of the B without the intersecting part, this. This is what common to outside of A and B. This is outside of A and B. What is common to those? That's this. Okay, so this is A intersection B bar, which will be part of the A that's outside B. And this is B intersection A bar, part of the B that's outside of A. Going to the part E, A union B complement intersection C. So can anybody tell me what that would be?
It's the area in the C circle without the intersections part.
It's the area of C without the intersecting parts. Is that what you meant? Okay. Yeah, I understand what you're saying. So I'm going to show that. Yeah, I think you got it, but I'm going to explain to everybody using this picture. A union B complement. First, you have to figure out what that is. So here's A, B.
Are we doing E or F?
Are you doing part E? Yes.
Okay.
Okay. So A and B and C, we are combining A union B, finding complement of that. I'm going to shade A union B complement first. This is my work picture. You can always draw a picture to do the work. So A union B is clearly the two circles A and B combined. So the complement is what I'm shading. That's not my answer. That's just work I'm doing. Complement of A union B. So what I'm doing right now is this, A union B bar. And clearly that includes part of the C. One student answered the question right, but I'm explaining to all of you. So the shaded region right now is the complement of A union B. The question is asking for A union B bar intersection C. That means what is common to A union B bar and C is the question. That's same as asking what part of the shaded region is in C. The shaded region is this, right? A union B bar. And what part of that is in C is the question. Isn't that this part right here? Right?
Yeah.
Yes. So that is our answer.
How did we get A union B bar?
Would be complement of the combination of A and B, the one I shaded here.
Okay.
Okay. You had to combine A and B and then shade outside of that. Isn't this A union B bar? When you have the three circles, it may look confusing. That's A union B bar, right?
Yes.
Okay. So now if I draw the C, you can see which part of C is shaded. This part, right? So the part of the A union B bar that's also in C is this. That'll be our answer. Okay, you got that? Okay, I assume you got that. Now I'm going to go to the next question, which is A union B complement union C. Let's draw the picture. And I want to see if anybody can tell me the answer.
It's the whole area outside the A and B circle, but with the C circle.
Whole area outside the A and B combined with
C circle.
entire C circle, right?
Yes.
Yes, very good. All right, one student is doing very good here. So I'm going to go step by step. A union B bar complement, just like before, you shade all of the outside of A and B combined. So that'll be this. So what I have shaded here is A union B bar. So what I need to do next is combine this to C. I need to combine this whole shaded region to C. And if I do that, what region will be added to the answer? Obviously, A union B bar is part of the answer. When you combine something, some more things will be added. What region will be added?
The intersections of C.
The intersection, the C is intersecting with A and B. This portion is going to be added. Because when you add the C, this part of C is already added. So this part of C was missing. Now it's going to be added when you combine the C. That part is added. So everything I have shaded now is the answer. So only a part of the A and part of the B are missed. Everybody's following that, or anybody has a question?
I have a question.
Yeah.
Would this be on basically on homework set 5?
Yes.
Okay.
Normally, the homework, when we did it on papers, I would ask you to have them shaded yourself, but now it's all on web design we have to do. So web design cannot ask you to draw these, do all these shadings, so they make it all multiple choice. So some questions would be in web design like this. It'll mark them, it'll put little check boxes in all these sections, and it'll ask you to check the boxes that are included in the solution. So you need to, if your solution is only this and this and this, you only check those. Understand? So you're essentially doing something similar to shading. You check the boxes of the sections that are in the part of the solution. So if this is in the picture here, if this picture is the solution, they will have boxes everywhere in each section and ask you to check the boxes that represent the solution. Then it will be this box, and this box here, this box, and this all have to be shaded, all have to be checked. So Vibhasan asked the question in these manners because they cannot have you shade anything. All right, going on to, we need to do one more problem before we finish. So question number G, 22G, A bar intersection B intersection C. All right, clear the board. Using a worksheet and colors would be helpful very often to figure out the solution. A bar intersection B intersection C. So here is, first I'll shade B intersection C, and then, so B intersection C, I'm going to shade in.
Would it be 2 circles, B and C?
What is common to B and C, right? Yeah, so this, I'm shading in black. This is B intersection C. Agree with that? Now the question is A bar intersection with that. So I need to shade A bar. I'm going to use red color for that. And then we'll figure out what is common. We are finding intersection, so we need to find what is common. So I'm going to shade A bar in red color. A bar is shaded right now. Okay, so can you see what region is red and black?
Yes, the center in between B and C.
B and C, but not including A, right? So I'm going to shade the answer in a different color. Okay. Can everybody see that this is the answer now? That's the region that's red and black, right? So that's what you shade as answer. Last question is B bar intersection A union C. Erase everything. Okay, A union C.
Would it be the two circles of A and C shaded together?
Two circles of A and C shaded together. A and C shaded together will be A union C, right? But we need to find B bar intersection A union C. Okay, so let me get there. Okay, so A union, I'm going to use colors. All right, so I have A here, B, and C. Now, A union C, I'm going to shade A union C. A union C is this, shaded in black. Oops, all of that. Okay. I need to find intersection of this with B bar. B bar means outside of B. So it's essentially same as asking what part of the shaded region is outside of B, isn't it? What is common to outside of B and A union C? Isn't that same as saying what part of the shaded region is outside of B? Agree with that?
Yes.
Yes. And what is that?
Shade everything, including the A and C circles.
Say, shade everything in A and C. All of the A and C, that would be this.
Yeah, you would shade around B, right?
Around outside of B, yes. Shade around the B. In other words,
And that would include A and C, right?
right. Include A and C, but everything outside of B though. You have to be what is common to A and C combined, and then B bar. What is common to A? This is A and C combined, A union C. And the question is, what part of this is common to B bar? B bar is outside of B. So what part of this is common to B bar is this, right? This is the part of A union C that's outside the B. Everybody's clear on that? Okay.
Yes. Just a question.
Yeah.
So for letter G, didn't we shade everything outside of letter A, including outside the circles and the circles?
For the G, everything outside of A would be A bar. We shaded what is common to A bar and B intersection C. I can do it again. We have a few minutes, okay. All right, I'm doing the G again. So let's get the pencil. A bar intersection B intersection C. So A bar would be everything outside of A.
I understand my confusion now.
Oh, you understand it?
Yeah, I mixed up the symbols of intersection.
Uh-huh.
And then I looked back at the circles. I seen my mistake. I'm sorry.
You understand? All right. Okay. Anybody having any question with any of these? You're going to be facing problems like this in the homework. So you need to ask your question if you have any.
Homework 5. It wouldn't include any like new problems, right? It would just have the problems we've been going over.
Yes, I always give you homework assignments on what we have done. And we normally do plenty of examples. You know, I do plenty of examples. I have right now here, I have 8 examples I just did. So yes, only homework will be on whatever we did. I won't give you anything that we haven't covered.
Okay, because I just thought that the homework assignments gone with the chapter units that we gone over, and I knew we were still on 4, so I just stopped.
Yeah, I already have the assignment set up, and I have some problems from the next worksheet because I thought we would be able to get to that, but we didn't have the time for that. So I'm going to delete those problems. So the problems will be only on worksheet this work.
Okay, that's what I just wanted to clarify. Thank you.
You're welcome. Yeah, I have some extra problems because I thought we'll get to it, but we didn't. So I'm going to delete them. So let me explain one more thing here. Some problems will ask you to check the boxes. Some problems will use answers like this: lowercase a, lowercase b, symbol letters, and then ask you to list all the elements that are part of the solution. So let's say your solution is this. Let's say that's your solution. Then you had to say the answer is the set consisting C, D, E. C, D, and E. You know, you have to answer that way. So different questions have different way of answering. If they have check boxes, you check the boxes. If they have these labels, A, B, C, D, E, F, then you use those labels to answer the question. But, you know, because you cannot shade, they have to ask the questions in this manner. Okay, so that's all we have time for.